Let's say that we have a CSV with a few columns. Let's say that we have 5 columns in the CSV. The 5th column is something that we are trying to predict, and we can use all the first 4 columns as inputs. So this is very standard. We have a CSV, we have columns, we have rows, and then some of the columns are the features. Those are the X variables. So the first 4 columns in our example are the input, they are the X, and the 5th column is the f of X, the function, the output of the function, or the Y. So it's simple, it's basic high school math, even before high school, intermediate school, because we have an input and we have an output, an X and the Y, an X and then f of X. And we are trying to predict the f of X based on the f of X that is already given to us. The first thing to do would be to load this CSV. If we use Python, for sure we use Pandas. And we do import pandas spd and then pd.read CSV. And then in brackets, the path to the CSV. The path to the CSV can be an actual HTTPS path to the internet. So pd.read CSV and the path to the CSV. Next, we want to extract the X columns and extract the Y column. If we say that our Y column is a single column, then we can take the data frame that we loaded with Pandas and do df our data frame dot drop and in brackets the name of the column that we are trying to drop. In data frames in Pandas, we need to pass another parameter. Axis is 1. Axis is 1 means treat it as columns. And in this way, when we dropped the last column, df.drop the last column, we get an X data frame, which contains only the first few columns. Then we want to get the Y data frame. The Y data frame is easily got with df, square brackets, and the name of the column that we want. Next, we want to split the data into test data, because let's say that in the CSV we have a few thousands of lines or more. We want to split it maybe to 20% test data and 80% train data. We can do this with scikit-learn model selection with a function that is already built in and is named train test split. So scikit-learn .model selection .train test split. We give this function both the X data frame, the Y data frame, and the ratio that we want, test size 0.2. The next step would be the actual model building. If we want linear regression, again, we would use the library scikit-learn, and then we would import from scikit-learn, scikit-learn.linear model, import linear regression. And then it's 2 lines. We built the linear regression model, and then we do linear regression.fit 2 parameters, the input and the output, the X for the train, the columns of the X inputs, but only the 80% of the train, and then the second parameter to the fit of linear regression is the Y column, but only for the 80% of the training. And next, we can simply call predict on this. So we loaded the CSV, we split it to 80-20% with another line. We create a model with another line, the dot fit. The dot fit is creating the model. And now we call dot predict, all on the linear regression object. Dot predict to get outputs. Next, because we have on the output of the 20%, we have already the results. We can just compare them to the results that we have. And we can use a few more functions given to us by scikit-learn. .metrics, mean square error, auto score. We pass to these methods the input, the training datasets, the Y, and the Y predicted. We pass into it the Y that was given and the Y that is predicted, and it would return to us the results of the actual model. In the same way, we can build other models. Instead of creating a linear regression model object, you would create a random forest project object. So this was a brief introduction into how to build a model. We use pandas.readCSV in order to read CSV. We then split it to train and test data with another function from sklearn. We then create a new linear regression object, and then we call the .fit method on the linear regression, passing into it the x of the training data and the y of the training data, and then we call the .predict in order to get a result. Very simple. Very simple, but the theory is hard behind it. But this was something very applicative.